in this case, that's the hardest part. Okay, so let me draw a picture in XY coordinates and try to understand things using that. Okay, so x and y go from 0 to 1. The region that we want to integrate over was just this square. Let's try to figure out how u and v vary in there. So let's say that we are going to do, let's say we're going to do it du dv. Okay, so what we want to understand is how u and v vary in here. What's going to happen? So the way we can think about it is we try to figure out how we are slicing our region. Okay, so here we are integrating first over u. That means we start by keeping u constant, no, by keeping v constant as u changes. Okay, so u changes as v is constant. What does it mean that I'm keeping v constant? Well, what is v? V is xy. So that means I keep xy equals constant. What does the curve xy equals constant look like? Well, it's just a hyperbola. Okay? Y equals constant over x. So if I look at the various values of v that I can take, for each value of v, if I fix a value of v, I will be moving on one of these red curves. Okay? And u, well, u is the same thing as x, so that means u will increase. You know, here maybe it will be 0.1, and it will increase to all the way to 1 here. Okay, so we're just traveling on each of these slices. Now, so the question we must answer here is, for a given value of v, what are the bounds for u? So I'm traveling on my curve v equals constant and trying to figure out when do I enter my region, when do I leave it? Well, I enter it when I go through this side. So the question is, what's the value of u here? Well, we don't know that very easily until we look at these formulas. So u equals x, okay, but we don't know what x is at that point. Well, u equals x and v equals xy. What do we know here? Well, we don't know x, but we know y, certainly. Okay? So let's forget about trying to find u, and let's say for now we know y equals 1. Well, if we set y equals 1, that tells us that u and v are both equal to x. So in terms of u and v, the equation of this in uv coordinates is u equals v. Okay? I mean, the other way to do it is say that you know you want y equals 1. You want to know what is y in terms of u and v. Well, it's easy. Y is v over u. So let me actually add an extra step in case that's... So we know that y is v over u equals 1. So that means u equals v is my equation. Okay? So when I'm here, when I'm entering my region, the value of u at this point is just v. U equals v. That's the hard part. Now we need to figure out, so we start at u equals v, u increases, increases, increases. Where does it exit? It exits when we are here. What's the value of u here? 1. That one is easier, right? This side here, so this side here is x equals 1. That means u equals 1. So we stop at u equals 1. Now, we've done the inner integral. What about the outer? So we have to figure out what is the first and what is the last value of v that we'll want to consider. Well, if you look at all these hyperbolas, xy equals constant, what's the smallest value of xy that we'll ever want to look at in here? 0, okay? Let me actually, where's my yellow chalk? Is it No. Ah. So this one here, that's actually v equals 0. So we'll start at v equals 0. And what's the last hyperbola we want to look at? Well, it's the one that's right there in the corner. It's this one here, and that's v equals 1. So v goes from 0 to 1. Okay? And now we can compute this. I mean, it's not particularly easier than that one, but it's not harder either. How else could we have gotten these bounds? Because that was quite evil. So I would like to recommend that you give it a try this way, in case it works well. Just try to picture what are the slices in terms of u and v, and how you travel on them, where you enter, where you leave, staying in the xy picture. If that somehow doesn't work well, another way is to draw the picture in the uv coordinates. Oops. Switch to a UV picture. So what do I mean by that? Well, we had here a picture in XY coordinates where we had our sides, and we're going to try to draw what it looks like in terms of u and v. So here we said this is x equals 1. That becomes u equals 1. So we'll draw u equals 1. This side we said is y equals 1, that becomes u equals v. That's what we've done over there. Okay, so u equals v. Now we have the two other sides to deal with. Well, let's look at this one first. So that was x equals 0. What happens when x equals 0? Well, both u and v are 0. So this side actually gets squished in the change of variables. It's a bit strange, but it's a bit the same thing as when you switch to polar coordinates at the origin. R is 0, but theta can be anything. Sometimes it's not always 1 point is 1 point. So anyway, this is the origin. And then the last side, y equals 0, and x varies, just becomes v equals 0. So somehow, in the change of variables, this square becomes this triangle. And now, if we want to integrate du dv, it means we are going to slice by v equals constant. So we're going to integrate over slices like this. And you see for each value of v, we go from u equals v to u equals 1. And v goes from 0 to 1. Okay, so you get the same bounds just by drawing a different picture. So it's up to you to decide whether you prefer to, think on this picture or draw that one instead. It depends on which problems you're doing.